So we're going to start looking at other ways to solve quadratic equations other than factoring. The first part of this lesson, we're going to go over something called incomplete quadratics. So your typical quadratic would look something like this. And the value of A is 1, the value of B is 5, and the value of C is 6. Now, when we have an incomplete quadratic, it means that this term is missing. So there's only an x squared term and a constant. So quadratics in the form ax squared plus c equals 0 are known as incomplete. Because these equations lack a linear bx term, they can be solved without the use of factoring and the zero product law. So what we do with these, first off, I'm going to move this 16 over on this first equation. You actually don't have to write this down. So I see that this quadratic could be solved by factoring, right? We could go through and do x plus 4x minus 4, but we don't need to. We can solve it a new way because we don't have the bx term. The x term is missing. So I'm going to erase this and show you the alternative way to solve it. Basically, we get the x squared by itself, and then we take a square root on both sides. So there's my square root. Now, whenever I take a square root when I'm solving, I'm looking for all possible numbers when squared that would equal 16. Now, I actually know there's always 2 because I could do 4 squared is 16 or negative 4 squared is 16. So when I put that square root on, I get 2 answers. I get positive 4 and negative 4. Anytime you put a square root on when you're solving, you have to get those 2 answers. So if we were going to write them in set builder notation, we could write negative 4 and positive 4. So looking at our next example, we have 500x squared minus 5 equals 0. So here, there's no x term, right? I only have an x squared and a constant. So I'm going to start to move things over until the x squared is by itself. Add 5. Divide by 500. So I get x squared equals 1 over 100. So at this point, we've isolated the x squared. Now we're going to take a square root of both sides. So that's going to give me plus or minus, right? 2 different answers. The square root of 1 is 1, and the square root of 100 is 10. So I can leave my answer like this. If I was going to write it in that set builder notation, I would have negative 1/10 and 1/10 as my answers. So why don't you try letter C? Remember, you're going to have to multiply by that reciprocal fraction at some point. So you can pause the video and then come back to see this one. Okay, so let's start to go over this one. Incomplete, right? I don't see any x term. So I'm going to subtract 4 from both sides. And then multiply by the reciprocal of that fraction to cancel it out. So you could type this in a calculator. If you were multiplying, this would give you 9 times 9 is 81. And as I said, we're not going to spend time. We've talked about that a couple times on the fractions, so you can use your calculator if you're not sure what to do there. So then we take a square root, and we get positive or negative 9. I could write it in this notation, but I'm going to keep the video a little shorter and move on. So we're going to continue with the same method for the remaining problems in this section. We're going to notice something a little different, though, on letter D. When I'm already set up to take my square root, which is nice, but I notice that 7 is not a perfect square. So what I need to do, I'm still going to write plus or minus the square root of 7, but that's as far as I can go. So that's my final answer. If I wanted to write it in set builder notation, I have a negative square root of 7 and a positive square root of 7. So sometimes with these, you have irrational answers. Moving on to the next one, and at any point you feel like you want to try these and then check, that's totally fine. I'm going to go through each of them though. So we have 3x squared equals 24. Divide by 3. So that's x squared equals 8. So now we'll take our square root. Now this one's a little different. 8 isn't a perfect square, but it does have a perfect square that goes into it. So you should have had a lot of practice on this in both Algebra 1 and Geometry. Basically, we take this radical 8 and we split it up into the perfect square, which is the square root of 4, and then what I call the leftovers. So 8 is 4 times 2. So I split it up into the part I can take the square root of and the part I can't take the square root of. I also need that plus or minus because we're solving, and we put a square root on. So we have plus or minus, square root of 4 is 2, and then the square root of 2 is irrational, so we leave it like that. So if we were going to write it in Step Builder, I'll do that for this one too, just because it's a little different. My two answers, I have negative 2 radical 2 and 2 radical 2. So why don't you try the next two, pause the video, and you can come back, okay? So here, hopefully you've tried them. Once again, all of these are incomplete quadratics. It's something we'd want to check for. If this problem was in a bunch of different types of problems, it's missing that x term. Here we have a fraction. So when we take the square root, sorry, that's just an equal sign there, I get plus or minus. Square root of 3 stays as the square root of 3. Square root of 4 is 2. So we have our two answers, negative radical 3 over 2 and radical 3 over 2. And when you're in Delta Math, you do have to type them separately, right? So you put that comma and then it'll pop up another spot to write another answer, which you should be used to from your zero product property problems. So lastly, we are going to add 20 and then divide by 2. And some of these really small steps where I'm just adding and dividing, you can do some of those in your head. I'm going to write out everything for the video, so if you have questions, you can see what's going on. So when I take a square root on this one, I get plus or minus. The perfect square that goes into 45, the largest one is 9, and then I have a 5 left. So this gives me plus or minus 3, radical 5. So I would have negative 3 radical 5 and 3 radical 5 as my two answers. One note, on Delta Math, they don't actually have questions like this, so I had to make them. So they're just single questions. So you might get them wrong, okay? And you don't get a new question. You just have to do the 5 that are there and do the best you can. And we'll go over stuff in class, or if you have questions, you can ask your teacher.